Okay, so now we're going to discuss two special types of patterns that happen, and it will be very helpful if you notice these and recognize this pattern that they make. The difference of squares is when you have a binomial and you're subtracting, hence the word difference, of two perfect squares. So if you have a squared minus b squared, it's always going to factor into a plus b times a minus b. For example here, you have x squared minus 9 becomes x plus 3 times x minus 3. You can still do the t-chart. Just understand what happens is your middle term, because it's missing, is a 0. So you have x and x multiplied to be x squared, what multiplies to be negative 9. You have positive 3 and negative 3, and positive 3x, negative 3x adds up to 0x, which is what works for this one. So you have x plus 3 times x minus 3. You can still factor these the same way the others did. Just understand if it's only the x squared term and the constant, that the middle term is a 0 if it's missing. So for the perfect square trinomials is when you have a square on each end, like this, x squared and 36. And then the middle term is going to be the square root of each of these, the x and the 6 multiplied together, times 2. So 6x times 2 is 12x. So what this factors into is x plus 6 times x plus 6, which is x plus 6 squared. And if you do the t-chart again, x and x, what multiplies to be 36? 6 times 6, 6x, 6x becomes 12x. So it's x plus 6 times x plus 6 equals 30x plus 6 squared. And for this one, you would do the same thing, x and x, because they're multiplying to be a positive and adding to be a negative, both of them would have to be a negative because they still multiply to be positive, but when you combine them, they combine to stay a negative 8x. So that's x minus 4 times x minus 4, which is x minus 4 squared. So go ahead and try these. Just use the t-chart the same way. So here are your answers. The first one, whenever you have a difference of squares, notice that basically in the t-chart, each column should be the same numbers. When it's the difference of squares, this constant part, one's going to be positive, one's going to be negative. So negative 5, positive 5, when I multiply across, negative 10x, positive 10x cancel out. That's my factored form. This one should have been the easiest one. X minus 7, x minus 7, x minus 7 squared. And for this one, this is where it starts to get really useful. If you notice that this first term and the last term are perfect squares, try it with their square roots. I used x actually, but it was y. But 3y squared, 4 times 4, when you multiply across, they do add up to 24. I'm going to still put x, but with this one it was a y. What you have to get used to is before you go start using the t-chart, or before you start factoring all of them, always check for a GCF, a common factor between every term in the polynomial. Okay, so 5x squared minus 20, because 20 and 5 both have a common factor of 5, you can factor that out. You still need to write it, but you can factor it out. And then I have 1x squared minus 4. And now, if you notice this, x times x, 2 and negative 2, 2x, negative 2x becomes 0. And I have x plus 2 times x minus 2. Be careful here because this is not your answer, because this is not the same as this. it's not equivalent unless it has this number that you factored out at the beginning. Don't forget that part. Now that's the same. So when there's binomials, it's either one of two options. Okay? If it's a binomial quadratic, you factor it one of two options. One way is that it's a difference of squares like this one, or the other way is like this, when you can factor out an x. Because both terms have at least one x, I can factor out an x. And I can also factor out a 2, because they both have a 2x that's in common. And so the 2 divided by 2 becomes 1. The x squared, I took 1x out, so I'm just left with that 1x there. Plus 8 divided by the 2, because I factored the 2 out, that becomes a 4. And I factored this x out, so there's no x left over. And now this isn't a quadratic anymore. I'm done right there. Okay? These can be really easy, but you have to recognize what to do for them. Okay, so when it's a binomial, it's one of two options. One of these two where it's a difference of squares, or you can factor an x out. And this last one, 6, 15, and 9 each have a common factor of 3. So I can factor out a 3, and I'm left with 2n squared plus 5n plus 3. Now this isn't my perfect squared trinomial special, but you can go ahead and factor 2n times 1n is 2n squared. 3 times 1, well, I can kind of see this is going to be 6. This is going to be 1. 6 plus 1 is 7. They're both positive. Double check that. I don't want to subtract them. So flip them. 1 and 3. That's going to be 2n plus 3n adds up to 5. Yay! So I have n plus 1 times 2n plus 3, and that's going to be my factored form. Wait, and I got to put that 3 that I factored out at the beginning. Now that's my factored form. Okay, so go ahead and try this one on your own. It's a little bit different. Pause it. If you can't figure out how to start, I'll give you a hint in a little bit. Okay, so if you couldn't figure out how to start it in this one, because this last term has an x, every term has an x, you can factor out an x. So I factored out 2 and x because they each have a 2 as well. And so when I factored out the 2, this became 1, this became 1, this became minus 12. I factor out an x, and each of those x terms decrease by 1. So pause it again and go ahead and try to factor the rest. And you should have gotten your answer x minus 3 times x plus 4, and they add up to 1x. Negative 3 and positive 4 multiply to be negative 12. But remember, you do need that GCF that you factored out at the beginning, that 2x.
Here's a 5-cent math tip.